Okay, I've been asked to go over this question, so let's have a look. The local government projects that the town will grow at a constant rate of 32%, so this is important, so I'm going to underline it, 32% per year. At this rate, determine how many years, so this is what we're looking for, how many years will it take for the town's population to be 5 times its current size? Okay, so I've underlined everything that is key words on here. This is an exponential growth problem, so we know that we want to use this formula, y equals ab to the x. And we just have to figure out what all these variables are in this context. So what we're doing is trying to figure out population. So instead of y, I'm going to use a p, so the population of the town. Now, A is its original population, and we weren't given any original population, so I can't put anything in for A. So I have to leave it as an A. Now B is how fast it's growing, and we're told that that's 32%. Now since it's growth, we have to do 1 plus 32%, and don't forget to change 32 into a decimal. 32% is 0.32. You have to move the decimal backwards 2 spaces or divide by 100 to get that as a percentage. And then X, in this case, represents the number of years, how many years that the population is growing. We can leave it as an X, or some people like to say number of years, so let's actually use an N there instead. So we'll be using N. Okay, now there's the model that we have. Now we have to figure out how to use this to find out what we're talking about. So this is what they're asking us to find, how many years, and how many years is the N. So I'm just going to take my, my color here. I'm going to circle what we're trying to find. Oops, a little bit too much there. Backstroke. Just circle it. Okay, so we're trying to find N. And we are told that we want to know how long it takes to get to 5 times its current size. Well, we don't know what its current size is, so we let A stand in for its current size. So what we want to know is how long it takes the population to get to be 5 times its current size. So 5A is what we want there. So I'm going to put the 5A in where the P is. 5A equals A, 1 plus 0.32 to the N. And since we have an A on both sides, I'm just going to divide both sides by A and it goes away. So I want to know how long it takes this decimal, 1.32, raised to an exponent. What exponent do I have to put on this in order to get 5? Now at this point, this is a bit of a guessing game. So you're going to take your calculator out and you're going to do a little bit of a guess and check to figure out how long it takes you to get to 1.32. If I pull my calculator up, I'm going to do 1.32 and click an exponent of, let's try 10 to start with. Now, when I do that, 1.32 to the 10 is 16.05. So that's way too much. So let's go down to 5. 1.32 to the exponent 5. That's 4.0. So we need to be somewhere between 5 and 10. So let's just go 6. 1.32 to the exponent 6. That gives me 5.28. So that's probably close enough. It's going to be somewhere between 5 and 6 years. So N equals about 6 years. And that's it.